Hi everyone, can everyone see the whiteboard and hear me correctly? Aside from my fat head being in front of the whiteboard. Okay, so today we're not going to go over a huge amount of new content. This is what week 5 now, we're about halfway through. We're going to go through and make sure we've got a good grounding in everything that we've done. So we're going to do some questions you would see in the what they call the simple familiar part of your exam. So multiple choice, the 1 and 2 mark questions, and we'll start to build into the complicated questions. So let's start with recognizing functional groups. What functional groups? Oh, here's Ross. Let Ross connect. Hi, Ross. So, what functional groups here? Let me pin myself so it doesn't. What functional groups are present here in this molecule? I'm going to do about 1 minute per question, I reckon. Feel free to answer in the chat. Here's a hint. You should see 2. Poppy says alkene. Anything else? Can't see the methyl group. So we have the alkene and we have the methyl group as well. Anyone want to take a stab at naming this molecule? Ross, I'm looking at you. Again, 1 minute, have a think. How would you name this molecule? So we've got a methyl group here, and we've got an alkene there. So Ross says methyl ethene. Correct. So we methyl, well, 1 methyl ethene, or eth1ene, but it's not an isomer, so we wouldn't name it. Okay. What functional group is present here? What functional group is present here? First question. What's its name? The bonding or the intermolecular forces, bonding type. And is there anything else I need to know? Again, 1 minute. What else though, Jacob? There's one more thing I'd be expecting in this answer. There's 3 different classes of this functional group. So the functional group, hydroxyl or alcohol, name would be ethanol, 2 carbons attached to an alcohol functional group. Bonding type, we have hydrogen bonding. Anything else, is it a primary, secondary, or tertiary alcohol? It is a primary alcohol. Because the carbon that the hydroxide group attaches to is attached to one other carbon. This is the way you should start thinking about all of this stuff. So I want you guys to be thinking about boiling point whilst I'm doing this. Which of these 3 molecules will have the highest boiling point ranked from lowest to highest? The lowest to highest boiling point. Again, classic exam question. So 1 minute. Jake says C, B, A from lowest to highest. So alkanes, we have dispersion forces. Here we have carbon to oxygen double bond. So we've got dipole, dipole. And then hydrogen. Bonus point question. If I was to draw a carboxylic acid would that change the order from CBA, or where would carboxylic acid slot in and why? See how mixed up I can make myself with wine. Oh, doesn't work. So if I added a carboxylic acid, where would it slot in that order? So carboxylic acids have 2 hydrogen binding sites, so they would go ahead of the alcohols. Minus 89 degrees Celsius, 40 degrees Celsius, 78 degrees Celsius, and the carboxylic acid would be 180 degrees Celsius. Right. Isomers. I want you to draw 2 different molecules that both have 4 carbons and 10 hydrogens. 2 different molecules, so 2 isomers of C4H10. So 1 minute for this one, maybe 2. And what would their names be? Classic multiple choice question. See, I've given you guys all the information to answer these questions, but what I'm trying to do now is develop your ability to actually apply that information independently before I go through it again. Wonder what a hydrocarbon is used for, or a haloalkane. Usually for a propellant. This is for just spraying air effectively. But in order to spray a gas, it has to have a propellant. And normally you'll find they're hydrocarbons. Hence why if I held a flame in front of that, you would get fire come out of it. At the moment it's just air. It's also being carried by liquid molecules of hydrocarbons. It gets really freezing cold. So that is difluoroethane. Okay, C4H10. First thing we do is we draw our straight chain alkane. Easy. C4H10. So we have butane. Then we could have but that's just 3 carbons. Boom, we add a methyl group. Would be 2-methyl propane. Butane, count the carbons, there's 4 carbons, 10 hydrogens. 2-methyl propane also has 4 carbons, 10 hydrogens. If you were to explain an isomer, you would explain it by there are same molecular formula, but a slightly different arrangement in the chain. Now this will test if you are listening. This is the cis. Draw me the trans isomer. This was in last year's exam. And 2 years before that. So I've given you the cis isomer. What I want you to do is draw me the trans isomer. The trans isomer is exactly the same, except we draw the hydrogens, or the bromine, doesn't matter, on the opposite sides. Cis isomer, hydrogens are on the same side. Trans isomer, they're on the opposite side. All right. How would we name that? So propanoic acid, very good, Poppy. Propanoic acid. What about if we made a, what would we call that? Propanol, because it's an aldehyde. I'm going to start ramping up the difficulty now. Jacob, what's the position of chlorine and bromine? And there's 3 carbons. Plug my speaker in, but I don't really need it. Think of it. Okay. So, Poppy, very close. So we number the carbons to give the lowest number possible to our constituents or our functional groups. So we have 1 bromo, 2 chloro, and then we have propane because it's an alkane. So we have to put the substituents in alphabetical order. So 1 bromo, 2 chloro, propane. All right, let's ramp up the difficulty now. Now, this is a question of my exam question list. 1, 2, 3, 4. Make sure I get this right. 8, 1, 2, 3, 4, 5, 6, 7, 8. All right, give me a second. I'll draw the carbons and the hydrogens. I hope this is relatively clear. And then off this carbon, actually not going to draw the hydrogens. You guys know what hydrogens should be there. So I'm not going to draw the hydrogens. You guys should know that they're there. So I'm going to give, this is like a 4-minute question. What would this be called? And it's, yeah, this is I'm going to give 4 minutes for this one. Remember, when we're naming the longest continuous carbon chain is our parent chain. This is like the most difficult naming question you'll encounter. So I'm not going to say a word for 4 minutes. Is 8 carbons the longest continuous carbon chain there, Jacob? Because the longest continuous carbon chain can follow the side chain. Well done, Poppy. The longest continuous carbon chain is 10 carbons. That's dead. So this becomes the longest continuous carbon chain, or 4-methyl, and Ross, 5-propyl decane. Well done. I'm proud of you guys. Not many students get that. I'll explain why for anyone that didn't get that answer. So we are following, when there's multiple chains, sometimes the backbone in a straight line is not the longest. Here, from here to here, it's only 8. From here to here, it's only 9. Here, this is now our backbone. This is now a methyl group. It's a 1-carbon side chain coming off the backbone. This is a propyl side chain. So to get the substituents or the side chains to have the lowest number possible, we count from this side. 1, 2, 3, 4 methyl, 5 propyl, decane. We put the names together. We put methyl first because of alphabetical order. Perfect. Well done, everybody. So this part of the unit is really honestly quite boring. But in order to understand the more interesting and more complex parts of the unit, of the organic synthesis, the industrial chemistry, we have to have a sound understanding of all this. Later on, probably next term, we'll start looking at how to make bulletproof vests out of plastic using these ideas. Okay, so let's just do a quick bit on solubility. So I'm going to try and get through a topic in the last 15 minutes. So are the following molecules soluble in each other? Are any of these soluble in each other? So 2 minutes. The dog whinging in the background, so she's being crate trained. All right, so propane and hexane both have dispersion forces. We remember solubility, it's like for like. Water has hydrogen. What do our aldehydes have? Dipole. Only the small aldehydes and ketones are soluble in water. So yes, but the small ones. Because hydrogen bonds are technically polar bonds. So they will dissolve into each other, just not perfectly well. Carboxylic acids have hydrogen bonds. Water also has hydrogen bonds. Ethanoic acid has 2 hydrogen binding sites, so it is very, very soluble in water. 4-methylproptene is just a hydrocarbon. So dispersion forces. Ethanol is hydrogen bonds. So we'll just, don't know where that was, will not dissolve in each other. I'm going to give you another one similar to this. So when you're talking about solubility, you're typically talking about water, 25 degrees at sea level pressure. So I want you to rank from lowest to highest solubility. So 2 minutes, rank from 1 to 5, which is most or least to most soluble in water. Classic 2-mark question. The background of chaotic kids upstairs. Nice. One more minute. All right, so we can immediately find the alkane, and it's going to be the least soluble in water. So dichloromethane is a haloalkane. The haloalkanes have very slight polarity. So the smaller haloalkanes will dissolve in water, So it would be, lost track of what I was going to say then. That would be the second one. Ethanol would be the third. Ethanol, fourth, 5. So also let's put that down, find some more questions. So I'm actually not going to try and go over another topic tonight. I'm going to do a few more questions. What else have we got? Let's really mix it up. How would you name this one? Get another 2-minute question. Sorry. So we're naming this, nothing just so good. All right, so we prioritize the alkene double bond. And we know that the longest continuous carbon chain is 4 carbons. Doesn't matter which way we go. Actually, no, it'd be 5. So what's the name for 5? Someone help me out. I always get 5 and 6 mixed up. Pent, thank you for copy. So we would name it immediately Pent 1 ene. What's attached? And where? So 3-methyl pent 1 ene. So remember you got the double bond there probably. So pentene. But I think we'll leave it there tonight, actually. If you sort of were able to follow along pretty well there, I wasn't expecting everyone to be able to answer every question straight away. But from what I saw in the chat, you guys got a pretty good grasp on this. So it ramps up quite quickly. We start looking at chemical characteristics, how to test for the organic compounds using simple tests this term. We'll then go into the simple reactions like substitution, addition, production, and then we'll start to look at, again, we'll go through the exam questions for those. They don't really get exam questions with regards to the topics we've already done. Don't really get much trickier than what we went through. Just thinking. So once we've done that, we then do esterification. So actually, we're now looking at how to build organic molecules from simpler ones. And then we will smash out some exam questions for the last couple of weeks, I think. I'll actually send them to you in a document. We can go through the last couple of years' exams, pick out the questions that relate to this term's topics, and make sure we're familiar with those, because next term it gets a whole lot more hectic. I will see you guys next week.